Today, we will talk about XLM, R3 Corda, and their extremely important connections into parts of Hyperledger. Today, we will be concentrating on Cacti and Besu, and that is because of the connections into Stellar, Cheesecake Labs, BIS projects, and even into BRICS, because I am convinced at this point Stellar is the public-facing BLT financial infrastructure. And here is an intro into Cheesecake and Cacti.
And one key point that I wanted to highlight is that because Stellar is very strong for payments, thanks to the very rich and unique on and off ramp infrastructure that Stellar has across many different countries, it can be very powerful to connect a private network like Fabric or Besu with this rich ecosystem of Stellar, and the possibilities are many. It really depends on what can make sense for your business.
That presentation is from Meridian 2024, where they were explaining how Cacti is used to connect into Stellar. And a huge advantage of being able to connect different kinds of institutional applications into Stellar is because of the speed and cost. Chainlink has had a ton of announcements recently where Franklin Templeton was explaining 50,000 transactions traditionally cost about $50,000 in total, whereas on Chainlink it costs them only $125. And it is an interesting example because Franklin Templeton was explaining the exact same example in terms of Stellar.
On the traditional way that we record a transaction, it cost us about $1 to do that. So for us to do 50,000 transactions on a traditional rail costs $50,000. 50,000 transactions that we've done on the Stellar network has cost us $120. So there is a huge cost saving, but then that cost saving also leads to efficiencies in the sense that you don't have to do the reconciliation of multiple ledgers, you don't have to remediate issues, everyone gets the same information synchronously.
And having a Hyperledger connector into Stellar can obviously provide other institutions the exact same kind of advantage. Bitt and DCMS are also involved with Hyperledger and Stellar in CBDCs. Ukraine is probably the most prominent example of that because they are currently utilizing Stellar to run the Prozora network, which is primarily concentrating on retail institutions and retail payments. One example of how Bitt and Stellar have been involved in that is called out here in an announcement from 2021. And there are also some interesting coincidences in between Bitt and their DCMS platform and BRICS Pay, because BRICS Pay is also utilizing a platform called DCMS, which was developed in Russia. It currently has 9 supported currencies, and there is published information on it as well. It is interesting because in here, it specifically calls out how Ripple and Stellar are not a good fit in order to compete with or replace Swift. And I think that's kind of interesting because especially Stellar, it is a completely public chain and it's been set up in a way that has positioned it as a politically neutral option as well. And it is calling out DCMS as its own solution and protocol here. So I'm still not really sure of the 2 different references to DCMS. I just find it oddly coincidental that it would be called the exact same thing as a platform that relies on Stellar. And I did call out Corda at the start, and that is because they are moving to integrate other platforms into the open missioned Corda platform. R3 is also heavily involved in Hyperledger projects and is referred to as a permissioned network in this overview put together by Tokenizer. And it's also important to talk about Corda, Hyperledger, and Stellar because of their involvement in a number of BIS projects. R3 is heavily connected into SBI, which also just so happens to be heavily connected into Ripple and XRP. They are also connected to Stellar. So Elliptic is a blockchain analytics company that has an exclusive partnership with Stellar since April of 2020. And it just so happens that the IRS uses Elliptic to combat AML-related activities. Referring to the BIS projects again, though, Stellar is specifically called out in Project Genesis. I have talked about it before because of ties not only into the HKMA, which has a lot of ties into Stellar, but because the project itself concentrates on Stellar architecture. In the Project Genesis 2.0 report from October of 2022, it is also referring to developments on Stellar as well. And to come back to DCMS and Stellar and potentially even BRICS are tied together, here is an overview explanation. And it's important because the information that I'm about to present, concentrating on Stellar, Besu, and Cacti, is all about providing a connection into Stellar. And if we are talking about BIS projects, CBDC pilots, retail institutions, and retail payments on top of BRICS infrastructure, and all of the different ties that Stellar has into that, it is an illustration of what the potential scale of adoption can be.
In the middle, we have our NUMA, our transaction system, and this is where we can integrate into the underlying transaction network. So see the blockchain and data stores here. This is interchangeable with different transaction networks. So for example, in the Eastern Caribbean, we've integrated with Hyperledger Fabric for the transaction network. And we're really excited to be working with Stellar on integrating with the Stellar network as transaction network. So our digital currency management system, as I mentioned before, it operationalizes these digital currency networks. So we integrate into the core transaction network, and then we put a number of our tools on here. So our APIs, our monitoring tools, central bank tool set, our routing system, our business logic. So these are all the things that central banks and financial institutions require to achieve some of the programmability and the uniqueness of their own digital currency deployment.
Cake has also been talking about Stellar and MoneyGram, which is able to provide retail on and off ramps that would be required in a financial infrastructure. Besu is all about connecting into private networks, such as what a financial institution would be operating internally. And Cacti is all about being able to connect into Stellar, where the presentation here is explaining a CBDC bridged in between Stellar and Besu, which enables cross-chain transactions.
So what we are trying to achieve is we want to tokenize a Brazilian bond for cross-network trading using Cacti, right, and the Stellar connector. I put this word here, and this is important, DREX. I don't want to go very deep on this topic because this is a whole subject, but I'm not sure if many of you know, but Central Bank of Brazil is issuing a CBDC right now, and it's called DREX, the DREX platform. And they are using Hyperledger Besu for the infrastructure behind the scenes. So that's why we are considering DREX on this specific use case. So this is what we are trying to achieve. So we want to tokenize Brazilian bonds from central bank in a public network, right, on the Stellar network in this case. We have the application layer here. Then we have the connectors, then we have the ledger. On this application layer, but here the difference is that we are working with decentralized applications. So we have one financial institution on one side handling one part of the services, and we have another company handling the tokenization piece with another service. So It's different infrastructure, different services, and they are communicating through this relay system on a very secure way. So going step by step, so the first step is inside of the Besu network, as the central bank has the CBDC there, the central bank needs to issue the Brazilian bonds, right, in form of digital assets, of course, inside of the Hyperledger Besu. Then the financial institution will buy those bonds directly from the central bank, and we will store those bonds into a wallet, a secured wallet. As this is a bond, the financial institution will receive yields from those bonds over time on this wallet, right? So this is the first step. With that done, another thing that we need to do is, so the financial institution will need to first bridge those bonds to the public network, and then those bonds will be split into shares, right? Into different portions on the public network. So the users can then buy those shares. As we bridge the bond to the public network, we break it down into shares, and then the user can now buy those shares. As this wallet is increasing in value over time because of the yields, this is also happening with the user shares, right? So the user shares are increasing in value over time because the main wallet is also increasing time over time. And another good thing about Cacti is that we don't need to stop there, right? We are connected with Stellar, like from Hyperledger Besu to Stellar, but we can do multi-network. So we can connect Besu to Stellar, to Polygon, and to a bunch of other networks. So Cacti allows us to do that, having a single source and multiple exits and multiple representations on different networks. So again, with the same infrastructure, imagine that we have Stellar plugged here. We can have Polygon, for example, plug it into the same assets on the Besu network using the Cacti solution.
Here is a video that is explaining interoperability in Stellar with Hyperledger Cacti. And I have cut it up into clips in order to call out the most important pieces relating to our topic today.
In terms of networks that we have delivered or we can deliver solutions at Cheesecake, I can name a few. Between those, Hyperledger, Fabric, Besu, and of course Cacti that we'll be talking a little bit today. Stellar on both Classic and now Soroban, Cardano, Ethereum, Polygon, and a few others EVM-compatible networks, and also Solana. In terms of solutions we have delivered, we did a few asset tokenization platform and projects on those networks. We do smart contracts implementations, we deliver DeFi solutions, and also a bunch of digital wallets. And this is where Cacti came as a great ally into all of these. Cacti is an interoperability framework maintained by the Hyperledger community. It's a graduated project, so it's there and is stable enough for us to start using.
Border with the money, take it to the different bank system. And if something happened throughout the way, and I cannot, for example, cross this border, I cannot just stop. That would be a problem. I cannot just leave the money there at the border. I need to go back and I need to revert all of my steps to make sure that I go back to the initial state. And that's very important because when we talk about this interoperability between different systems, it means that we are trying to make an atomic transaction in a sense that either everything happens or nothing happens. I cannot stop in the middle. Stopping in the middle is a problem. I could be doing a double spending, generating money, destroying money. I could create a big problem. So a portion of the space of what we're trying to solve is understanding this gap and understanding the kind of recipe I have to apply to cross the gap safely and not stopping in the middle. So here in the first one, they call it the data transfer. It's basically moving data from one side to the other. When would that apply? Let's think of, for example, a Ethereum market that wants to sell tokens or provide some kind of portfolio rebalancing based on the volume of Bitcoin transacted in the last hour. So we would have a system in the middle that would look at the Bitcoin network to see what was the volume every hour, collect this data, and input this data into the Ethereum network. So what is the kind of recipe you need here? You need to orchestrate the step to look into one blockchain, to bundle this data, create a transaction, and process this transaction on the other network to input this data. The next one, it's about asset transfer. So basically, I have a representation of some sort of asset on one side, and I want to move this representation to a different network. So I want to have my asset on another network. Like, for example, Bitcoin exists in the Bitcoin network. So how can I use Bitcoin on the Ethereum network? There are also different ways people tackle this problem. And one of the common ones that's represented here is wrapping an asset. So for example, they would get the Bitcoin on the Bitcoin network. They would lock that asset in a safe way, generate some sort of proof or evidence that it's being locked. And based on this evidence, they would generate a representation of the Bitcoin on the Ethereum network that is tied to that representation. So people can use this representation on the Ethereum network. And once they want to redeem, they just destroy the representation, generate a proof of that, and then they release the original asset on the original blockchain. There are other ways of doing that. You don't always need to lock an asset. Like, for example, something closer to a CBDC approach. You could basically manage the supply and destroy units on one side and recreate on the other, making so that the asset actually jumps from one network to the other, and you don't have like locked supply. You have just one moving representation of the asset in different networks. And you can also take different flavors of how you deploy your application. So here, it's a simplified view in which you have the blue arrows and the orange arrows. Blue arrows is like one approach, and orange arrows is a different approach. With the orange arrow, you have one standalone application, the node server, which is, think of it like one entity or one company controlling both ends. They're controlling the whole use case to bridge something from chain A to chain B, and they can simply combine the components and build this very easily with the framework to handle the whole use case. Now, if you want to do something with different entities, like, hey, me, FIFO, here in Brazil, I am specialized in working with the Brazilian markets and the Stellar network, and I want to connect with Doug, who works in the US and specializes in the Ethereum ecosystem. That's perfect. I'll handle my solutions here with my standalone and relay, and I'll connect with his solutions, and everything will be well orchestrated through the framework to make sure we are following the same rules, we are communicating in a safe way, and we are getting to the points that we want, which is an interoperable and seamless solution. So that's very, very powerful. And we have a public permissionless network like Ethereum. We have a permissionless network like Fabric running on a private environment, probably, and we have Corda on the bottom, and you can have any kind of solution or blockchain, and then they're connected through different ways. You see in the middle, you have data sharing, asset exchange, asset transfer. You have those different modes implemented in different ways. We have just one connection of node serve with asset exchange. You have two relays interoperating between the networks for data sharing. You can also connect to an enterprise system. You can connect to decentralized identity registries. So you can really borrow from those components, create a unique use case, like using Lego pieces to overcome a specific problem, and deploy in different environments. And as the framework grows more over time and improves over time, we can get more and more people coming with very unique use cases. And we don't have anymore the silos of separated chains that only work with certain scenarios. We have a more seamless experience for the end user that can trust on specialized chains for specific actions, but also be connected to other chains on different sides of the world. And we wanted to bring a little bit of our expertise in Stellar to the Cacti project. So we started by building the Stellar connector. So the Stellar connector, it's basically one of those components that is specialized into talking to Stellar, handling the Stellar use cases, and helping anyone build in this ecosystem as well. Stellar has some very unique ways of connecting and of managing assets and managing their transactions. So we chose to use Serban, which is a very new environment they created for smart contracts, just came out this year. And we wanted to bring a welcoming way of developers to connect with the ecosystem with something that they're familiar with. So it's kind of the same way of building the recipes and building the solutions. In the future, we want to improve and bring the classic way as well, which I think is going to be very rich to get scalable, cheap transactions. What we built was, we had the connector, and we could now interact with the Stellar network. We could interact with it through the Cacti framework, but we wanted to take a step further. We wanted to put it to test and build an actual use case while thinking about the real world assets and real use cases. So some of you might be familiar with the Drex project in Brazil that is going to use Hyperledger Besu to experiment with a CBDC here in the Brazilian ecosystem. So we have been running a lot of experiments with Besu and connectivity, and we wanted to test that with the Cacti as well. So what we did is that we borrowed from another demo that existed in the Cacti project, which was a demo for a cross-border asset exchange using Besu and Fabric. And on the right side here, you can see we have a Stellar side, and on the left side, we have the Besu. So what we did is that we took out the entire Fabric portion, and we implemented the Stellar portion for doing that. So on the bottom, we have the connector talking to the blockchain. We created some smart contracts in Rust to carry on specific actions on the Stellar network. All of these are in the project. And then we created the gateway that connects with the Besu side and orchestrate all of these steps. So in this demo, we have two users that want to move an asset from one network to the other and transact on both sides and play around with those tokens. And Alice wants to send some funds from her Stellar account to Charlie, who is using a Besu account on a Besu network. So how can Alice cross this gap? The way we do it, Alice sends some funds to a bridge, to an application, and this bridge has an account, and we have smart contracts that manage this process. And she generates a lock. She escrows these funds on the bridge and gets a unique identifier, some sort of proof that this asset has been locked. So with this, she takes this proof, goes to the bridge in the other network, and use this proof, this identifier, to generate a representation on the other network. So that means on Stellar, her asset is locked, safety locked, and this lock is pointing to the existing representation on the Besu network. So while this representation exists on Besu, the lock cannot be removed, and it's only going to release the original assets once the representation stops existing. So Alice gets this representation, and she then shares with Charlie. She sends some tokens to Charlie on the Besu network. Now on Besu, Charlie can use the token as he wish. He can use DeFi applications. He can share with other people. He can transact normally. And when someone wants to bridge back the asset, they just need to go to the bridge and say, hey, I want to redeem the original one. So the bridge is going to orchestrate the destruction of the representation and the release of the original funds on the original network. So even though Alice was the one sending the tokens to the other network, creating the representation, Charlie can be the one redeeming the asset on the original network and getting the token back on Stellar. Hope the GIFs play. So in this screen, here in the first step, we're just setting up the accounts. So we are just minting some units of the token to Alice. On the left, we have Stellar. On the right, we have Besu. And here's just to exemplify that this is a normal token that you mint, you transfer, you can do movement for different accounts. So here, Alice has 1,000 units, and then we send 500 to Charlie. So now it's just repeating. And down below, you'll see we have this bridge account, which we're going to use in the next step. So here in the next step, Alice is holding 500 and Charlie 2. Alice is going to escrow 250 units. So when she does that, we are using the bridge to send the funds to the bridge. You can see that Alice now holds just 250. The other 250 are in the bridge. And in the next step, she will confirm that she wants to do the transfer. Now, before I move to the next slide, I want you to pay attention down below here. Alice is going to send 250 to the bridge and Charlie 2. So once they do that, we get this ID, this unique ID below for each one of the escrowed amounts. So the bridge tracks individually these different scrolled amounts and these different references to ensure that as many users as you want and as many accounts as you want can interact with it in a seamless way. So they're creating these different escrowed amounts. So in the next step, now it's time to move the asset to the other network. So Alice selects the escrow amount she has, 250, and she say, hey, I want to bridge to Besu. And that's very quick. There you go. So Alice just sent 250. You can see that the Besu side is going to receive 250 tokens, and these tokens are the representation that are backed by the value that we have here in the bridge. So you see the bridge here has 350 tokens. 250 are fully locked because of the representation, and the other 100 are representing the escrowed amount from Charlie that he didn't bridge, but is there waiting to be bridged or to be redeemed if he wants, because it's not locked yet. So once Alice has the tokens on the Besu side, she just can use it as any normal token. So what she does, she fractionalizes and sends some units to Charlie. So now she's going to choose Charlie on the Besu side and is going to send 150 units. So she'll do a normal transfer. Charlie received it immediately. And now Charlie can choose if he wants to escrow some amount and bridge back. So that's what he's going to do. He's going to do the same process on this side. The only difference is that on this side, once you select the bridge back, instead of locking the asset, you're actually destroying this temporary representation, and the bridge sends the funds back to Charlie on the original network. So here you can see, before they do the step, the bridge has 350. And once Charlie confirms that he wants to send the 150, they are going to appear in Charlie's balance and be moved from the bridge after the representation is destroyed. It's very fast. It happens very fast. But under the hood, we're talking about dozens of transactions, dozens of steps, a lot of communications between these two systems, and signed communication to make sure you're talking to the guys you're expecting to talk, you're coordinating through the steps, and you're verifying each step you take in the process.